Hello, and welcome to UPL Insights, a new digital media series from UPL, led by our teams changing the game for farmers across the African continent. This series will bring together leaders in sustainable farming, food systems, and climate resilience to explore the challenges and developments defining world agriculture today. We are recording this episode ahead of the African Green Revolution Forum, the biggest annual agriculture event for Africa, which is now marking 20 years of Agra's mission to transform agriculture. This year, the AGRF Summit is a virtual event, and we have been talking to some of the people leading that transformation inside and outside of UPL, and exploring our shared commitment to resilience, trade, nourishment, and sustainable productivity. Today I'm joined by Kevin Ashford, Global Technical Development Lead for Water and Soil Solutions at UPL. Kevin has spent his career looking at the physical, biological, and chemical character of soil varieties worldwide, using this expertise to advise farms and farmers on how to set the conditions to help plants reach their greatest potential. Today we are going to be talking to Kevin about water. The importance of water to agriculture needs no explanation, but the quantities involved may be surprising. For instance, it takes 20,000 kilograms of water to produce 1 kilogram of cotton, and just 500 kilos to produce 1 kilo of potatoes. Most of the countries in the African continent that produce food and cash crops are strongly affected by climate change, which makes unpredictable rainfall and degrading soil the new standard. Kevin is one of the people who has been leading the efforts to solve this problem. For the last 4 years, Kevin's work has focused on scaling one of UPL's most innovative and high potential soil and water technologies. The solution is called ZEBA, and it is changing the way plants and farmers rely on water, even in some of the most arid, drought-affected regions worldwide. Kevin, welcome to UPL Insights. Can you tell us how the soil's physical, chemical, and biological structure influence the yield and how ZEBA can improve it?
Hi, Florence. Yes, and thank you very much. Soil is a very dynamic environment, and it is driven by the interaction of the physicality parts, the biological parts, and chemical reactions from things like calcium, magnesium. The way we work it is the physicality with the plow or the tractor, and the biology is the soil microbiome. All these things require water to be the central conduit for them to function. ZEBA, a product from UPL that I've been working with, is effective in all of these areas. It becomes a pivotal part for the chemical, physical, and biological process in soil. ZEBA is fundamentally a corn starch paste superabsorbent material with a neutral pH. It has the ability to superabsorb water up to 500 times by its weight. So as a small granule, it's got a massive influence on the soil environment and the way water can be managed. It has repeated hydrating phases, so it not only takes that water in, makes it available for plant and soil process once, but it can do that several times by drying and reabsorbing. It's also very biodegradable, and most important for the very topical points these days, it has a carbon base as well, so it can sequestrate carbon back into soils.
That's fantastic. Sounds amazing. Can you tell us a bit more about the challenges the world faces with water and how exactly agriculture is impacting on that?
Yes, agriculture is having a major part to play. It's as we increase crop production to feed the world, it's not just food that's at stake, but industrial crops. The process of agriculture per se means that we're growing a lot more crops on a limited amount of ground, and water is required. So the more you express for yield, the more water you will require to produce that yield. And it has a footprint here. The blue, green, grey water footprint, as is often benchmarked around the world, has a relevance here. If every crop has an amount of water that it uses, So therefore, if we increase yield from the same amount of water, you effectively reduce the footprint. So our objective is to make the plant very efficient in its use of water, not have excess irrigation that leaches, not have excess evaporation from soil, to ensure that each crop that we use is being optimized by its growth pattern for water. Therefore, we have a very small or reduced footprint on the environment. Take an example of cotton, for instance, versus potatoes. Potatoes will need about 500 to 700 millimeters of water to produce growth, and they will produce about 50 to 70 tons of yield per hectare, where in contrast, cotton requires very high amounts of water, from 700 to 1300 mils of water, yet it only yields up to 2 tons. So dividing the output by the amount of water required to achieve that output makes it very, very consuming of water. So if we can increase the efficiency, reduce the waste of water, increase the efficiency of crop production to water, is to our advantage.
Excellent. Yeah. So we now understand how Ziba can improve the water footprint of agriculture, and I want to enter into a bit more details on what are the exact benefits of Ziba on water retention and control, maybe soil quality and fertility improvements.
Yeah, the best direct example I can give you was a study that was done in very, very dry conditions in the Middle East in 2017, as one example, where we had able to achieve a 6.6% yield increase. That 6.6% yield increase was also achieved by the use of Ziba as a product in the mixture, a 17.6 direct water saving. So just playing with those two figures, you end up having a 22.7% saving per ton of production in water. So it's very important not just to save water from leaching and evaporation, but to also have a product that can increase yield. So management and water conservation are critical to the future and savings of water in the environment.
Yeah, absolutely. I follow you there. And I guess if we reduce the use of water and if we improve the quality of the soil at the same time, does it mean that we can reduce the use of fertilizers?
Yes, if you take, let me just quote you two examples here. I mean, you have soils around the world that are becoming very low in carbon. Carbon is a big topic, and carbon is what helps to hold water and soils together. So an example would be in Texas, where you have soils that are very, very sandy. They're blown all over the place. There's no structure, very easily degraded. They're washing out into the sea, into watercourses, polluting the environment. It's effectively what we call dirt. It's no life, very hard to grow crops in that, and very low in nutrition. So not a good scenario. Whereas in contrast, we have this very, very good soil, a soil that's darker in color, containing organic matter, able to hold nutrients and water, can hold and support microbial communities that demineralize nitrogen and nutrients for the benefit of plants, able to hold yield aspirations. Effectively, what this delivers is resilience. Farmer, but soil resilience for our future. And our future is needing to be sustainable. Very much so.
Sounds revolutionary, Kevin. Thank you so much. Basically, the soil health has definitely a role to play in the use of water and in water efficiency, I guess. Can you elaborate a bit more on how does soil health relate to water efficiency exactly?
Sure, Florent, yes. I mean, what you have to understand is two things. We need every crop needs a certain amount of water to produce what it needs to produce to live, and we all do. The difficulty comes in twofold. We have a situation where we have very suboptimal water, not enough. And when you don't have enough water for growth, two things happen. A, the plant can't drink, and B, the nutrients in the soil can't become solubilized and available for the plants to drink. So Nutrient use efficiency, we call this, and water use efficiency is very, very suboptimal, and you get lower yields. The opposite of this is excess. If you have too much water, over irrigation, over use of water, the plant can't breathe, you get an anaerobic environment where, again, yields are suppressed. So we have this area where you have 25% water, 25% air in a soil environment, where Zeba is very, very functional. And where it functions best is you're optimizing water, optimizing nutrient use efficiency, buffering against suboptimal conditions, and equally offering a management tool to limit or reduce the excess water applications. It gives the confidence to the grower that they're not putting on excess water or don't need to. This translates into yield as well. You know, many trials we see around the world. In particular, we can see that where we apply 100% irrigation and fertilization, Zeba can produce good benefits. But it's interesting, we don't know if that 100% irrigation is in excess or suboptimal. So we often do a test. So we reduce our water irrigation to 30% and 50% irrigation. Surprisingly for Zeba, many times we do this, we see yield improvements or standardized yields against control. So there's much scope to reduce our irrigation management strategy in conjunction with the use of a product such as Zeba, and equally then adjusting our fertilizer strategy to avoid pollution into the environment.
Very, very interesting, Kevin. I now really wonder how can we use it? Have you tried Zeba on a big number of crops? Does it perform better on some crops than others, for example?
Yeah, there's slight variations between crops based on how much water they consume ultimately. But sure. It's about soil. Soil drives everything at the end of the day. Soil determines whether you can hold that water, hold that nutrition, support the nutrition that the plant needs when it needs it for its growth. And Zeba, in this role, is universal. It interacts with soil. The plants then put their roots into this soil substance and draw what they need from it to sustain their life and production. So Zeba is a very strong conduit. It's in the process. It's not magic. It's a very, very fundamental requirement in soil to help it be more balanced. You still need your fertilizer. You still need your irrigation to a certain degree, and you'll still need your soil process, your biology. But Zeba, across all soil types, across all crop types, interacts in the same parameters: soil health, water conservation, nutrient management, microbial microenvironment within the soils, whilst protecting against the environment from leaching, excess leaches and leachates into the environment, and degradation and structure. So it's a very, very rounded material.
Sure, and I feel this is very relevant also to the African context when we know that Sahara is still expanding, leading to food insecurity. Rainfall patterns are also more unpredictable than ever. Farmers are really facing new challenges every day, and how can Zeba help them adapt to these new conditions of climate change, weather unpredictability, poor fertility, also soil degradation? If you say it's not so much about the crop, but rather about the soil, I feel there is a great potential for African farmers.
Very much so, Florent. Yeah, indeed. And one example would be the Great Wall Initiative that's currently in the a lot in the press and a lot in the forefront of people's minds. But as an example, we can give you, Zeba is very, very flexible. As a granule, it can be manipulated into many different applications, from direct soil application to incorporation in many different folds. One in particular, in respect to the Great Wall, is where we can incorporate within substrates. So when nurseries are producing substrate stock, plant stock, and in Great Wall Initiative, tree stock, we can support that production in the nursery position, reducing the water requirement there. So when that tree is planted into the open environment, again, Zebra can be a support mechanism for those trees. These trees cost a lot of money. They cannot afford to be replanted so often. So the more we can do as a collective to ensure their survival, ensure they get established fast enough, vigorous enough to create their intended purpose, the better. So everywhere from agriculture to forestry situations, Zebra seems to have a role to play, because again, it goes back to the fundamentals of soil and soil health and the way that roots interact and plants interact with that environment. So, Zebra has this role to play, and I believe in its flexibility and versatility, it can offer a high level of resilience to the growers' management of their farming situation or industrial situation, and also the resilience to the soil, buffering a lot of the negative environments that are proposed upon it, from degradation of soil to loss of carbon, and ultimately the better management of applied or acquired water supplies.
Absolutely. Well, thank you so much, Kevin, for taking us on this journey on soil health and water and the great potential of ZEBA. To find out more about UPL work on ZEBA soil health and water, you can click the link in the description of this video. And you can also subscribe to this channel to follow our full podcast series for the AGRF. Thank you.
Thank you.